To find this video for place value, I'm going to go into classwork, and then for my topic, I'm going to pick digital room. I'm going to find our math digital room. I'm going to look at our videos, place value videos, and there's one left that we haven't read yet, or sorry, haven't watched yet. This one's about expanded notation. We watched 2 different videos about reading numbers. Yesterday we watched one about how every time the number goes up in one place value, it gets 10 times bigger. This one's about expanded notation. Really quickly, with a show of hands, I want you to raise your hand if you've ever heard of expanded notation before. Sometimes people will also say expanded form. So if you've heard of expanded form or expanded notation, raise your hand. Okay, so a few of us have, some of us haven't. That's okay. Since we're going to watch a video, go ahead and turn your camera off for now, so that way the video runs a little more smoothly on our screen. Let's make sure we all have our cameras off, that way the video runs nice and smooth for everyone.
Hi, I'm Rob. Welcome to Math Antics. In this lesson, we're going to learn how our basic number system works, and we're going to learn about an important concept called place value. The number system that we use in math is called base 10, because it uses 10 different symbols for counting. Math could use other systems that are based on a different number, like base 2 or base 8, but I'll give you 10 guesses as to why the number 10 is such a popular choice. The 10 symbols that we use are called digits.
Before he goes any further, we see another pattern. We saw yesterday how every time number goes up in place value, it gets 10 times bigger. He says that our digits are what they call base 10. And again, he said, I'll give you 10 guesses as to why the number 10 is such a popular choice. And then he holds up his hands. So when they were making our numbers, why do you think they chose 10? Who can tell me? You can just go ahead and unmute your microphone and let me know. Why do you think they chose 10? What made 10 the best choice?
Because it is above 1 and 9.
It is above 1 and 9, but there's a lot of other numbers that are like that. Popular, not because it's popular, Sebastian. Think about what he did. He showed us his hands. Why would he show us his hands, and what does that have to do with the number 10?
Because it's 1, each hand is 100.
Not because it's 100. It does have something to do with our hands. Take a look at your hands. So take your hands, put them out in front of you right now. Chase, what do you think? Why do they choose the number 10? 10 fingers, perfect. If you're counting on your fingers like we usually do when we first learn to count, we have 10 fingers. So when they chose base 10, it was probably because we have 10 fingers, and that made it easier to keep track of things in groups of 10.
The 10 symbols that we use are called digits, and they look like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. At first glance, you might think that that's only 9 digits, but remember, the 0 counts as one of the digits also. To see how our number system uses these digits to represent amounts, let's pretend that we have an apple orchard full of apple trees, and each of these trees is loaded with big, juicy red apples that we need to pick and then count for our records. We're going to use something called a number place to count. The best way to understand a number place is to imagine that it's like a small box that's only big enough to hold one digit at a time. As we count, we'll change the digit that's in the number place to match how many apples we've picked. For example, if we start with no apples at all, we put the digit 0 in the number place, because 0 means none. But then, as the apples start coming in from the orchard, we begin to count. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, now we've got 9 apples, but we've also got a problem. We've already run out of digits to count with. The highest digit we have is a 9, but there's a lot more apples left to count. What will we do? The solution is to use groups to help us count. If we pick just one more apple, we'll have 10, right? So let's combine those 10 apples into a single group. So, how many apples do we have? 10. But how many groups of 10 apples do we have? Just one. Does that help us with our lack of digits problem? It sure does, if we use another number place. Instead of using this new number place to count up individual apples one at a time, like we did with the first number place, we're going to use it to count apples 10 at a time. In other words, we'll use it to keep track of how many groups of 10 apples that we've picked. For example, if we've picked only one group of 10, then we'll put the digit 1 in that number place. If we pick two groups of 10, then we'll put the digit 2 in that number place. And if we picked 3 groups of 10, then we'll put the digit 3 in that number place, and so on. Do you see what's happening? Because the new number place is being used to count groups of 10, it's allowing us to reuse our original 10 digits. But this time, they're able to count or represent bigger amounts. Since this new number place is for counting groups of 10, we're going to name it the tens place. And we'll name our original number place the ones place, because we used it to count things one at a time. And here's the really important thing. We're not going to use the new number place instead of the old one. We're going to use it alongside of the old one, so that we have one number place for counting by ones and another number place for counting by tens.
That's why we have the different place values. Because like he said, there's only so many digits we have. They only go up to 9, but there's numbers that are much, much bigger than just 9. When we start to use more than one place value, we're able to show these bigger groups of numbers.
Using these two number places together lets us represent amounts that are in between the groups of 10. For example, if we've already picked 30 apples, then there'll be a 3 in the tens place because we have 3 groups of 10. But there'll be a 0 in the ones place because there are no individual apples left over. But if we've picked 32 apples, then there will be a 3 in the tens place and a 2 in the ones place to represent the 2 individual apples that are not in the groups of 10. In fact, using only our 10 digits and these two number places, we can count all the way from 0 up to 99. At 99, both of our number places are maxed out with the highest digits, and we won't be able to count any higher unless we get another number place. If we've picked 99 apples, and then we pick just one more, we'll have exactly 100 apples. And if we make a group from those 100 apples, we can use this new number place to count how many groups of 100 we've picked. That means that we can reuse the same 10 digits again in this new number place to count how many groups of 100 we have. And you guessed it, it's called the hundreds place, because we use it to count groups of 100. Are you starting to see how our base 10 number system works? It uses different number places to represent the different size groups that we use to count. And the digits in those number places tell us how many of each group we have. The digit in the ones place tells us how many ones we have. The digit in the tens place tells us how many groups of 10 we have. And the digit in the hundreds place tells us how many groups of 100 we have.
And just like yesterday, we see that there's that pattern. 10 ones will make 1 10. And then 10 tens will make 100.
Your mic is on.
So it's the same pattern over and over.
And have you noticed that each time we got a new number place to count larger groups, we placed it to the left of the previous number place? That's important because number places are always arranged in the exact same order. Starting with the ones place, as you move to the left, the number places represent larger and larger amounts. And did you also notice that each new number place represents groups that are exactly 10 times bigger than the previous number place? 10 is 10 times bigger than 1, and 100 is 10 times bigger than 10. That's really important because it helps us see the pattern for even bigger number places. It helps us to see that the next number place will count groups of 10 times 100, which is 1,000. And that's why it's called the thousands place. And the next number place will count groups 10 times bigger than that. It's the 10,000s place. And the number places keep on going like that. Next is the 100,000s place, then the millions place, then 10 millions, then 100 millions, then billions, and so on. Oh, and you may notice that when we get a lot of number places next to each other like this, it's a little hard to quickly recognize which place is which. That's why many countries use some kind of separator every 3 places to make them easier to keep track of. For example, in the US, we use a comma every 3 number places to make it easier to identify things like the thousands place or the millions place.
So like you said, we make those groups of 3, those periods like we had seen the other days. And usually we'll put commas in between so that we can see, oh, here's one group of 3, here's another group of 3, another group of 3, and then if the number is even bigger than that, we'd have another group of 3.
Seeing all these number places together helps you understand what we mean by place value. In a multi-digit number, the number place that a digit is in determines its value. Even though we only have 10 digits, each digit can stand for different amounts depending on the place that it occupies. If the digit 5 is in the ones place, it just means 5. But if a 5 is in the tens place, then it means 50. And if a 5 is in the hundreds place, it means 500. And it's the same for bigger number places. A 5 in the 100,000s place means 500,000. And a 5 in the billions place means 5 billion. See how a digit's place affects its value? Of course, when we work with numbers in math, most of the time the number places are invisible, but the underlying pattern is always the same. Oh, and because the number places are invisible, in certain cases you'll need to use zeros to make it clear what number you're talking about. To see what I mean, imagine that this 5 is in the hundreds place to represent 500, but if you make the number places invisible, then it just looks like 5 and not 500. So, to make sure people know you mean 500, you need a 5 in the hundreds place, a 0 in the tens place, and a 0 in the ones place. Now you can tell that the 5 is in the hundreds place and it means 500. Okay, now a great way to see place value in action with some actual numbers is to expand them to show that they're really combinations of different groups. When we do this, it's called writing a number in expanded form. For example, we can expand 324 to be 300, 20, and 4. Because the 3 is in the hundreds place and means 300, the 2 is in the tens place and means 20, and the 4 is in the ones place, so it just means 4. So 324 in expanded form is the combination of those amounts. 300 plus 20 plus 4. Let's try writing another number in expanded form. 6,715. We can expand this into 6,000 because the 6 is in the thousands place, plus 700 because the 7 is in the hundreds place, plus 10 because the 1 is in the tens place, and 5 because the 5 is in the ones place. So the expanded form is 6,000 plus 700 plus 10 plus 5. All right, so do you see how our base 10 number system works? Number places are used to count different sized groups. Each group is 10 times bigger than the next, and the digits in the number places tell us how many of each group we have. The tricky part is that the number places are invisible, so you have to know how they work behind the scenes in order to make sense of multi-digit numbers. How do you like them apples? The exercises for this section will help you practice so that you get used to how place value works, which is super important if you want to be successful in math.
Okay. We can go ahead and turn our camera back on. We're going to continue practicing with our place value, and today we're going to practice reading our numbers. We're going to build some numbers, but we are also going to practice using expanded notation. Okay, so expanded notation is when you break up a number using the place values. I'm going to leave a blank slide here for us. We can practice. All right, first we're going to build a number. So I'm going to build a number here, and then we're going to practice breaking it into expanded form or expanded notation. We're going to start off, we'll start off a little bit small since we're going to practice expanded notation also. Okay, who can read that number for me? Bella, how would you read this number?
4,542.
Okay, perfect. 4,542. Now, what I'm going to practice doing is here, actually, we had 4,542. Let me do this. Okay, 4,542. If we break it up into place values, there are 4 digits, right? Which means there are 4 place values. The first number, the first digit, who can tell me what that first digit is? Bella, what was the first digit?
4,000.
4,000, and perfect. So the first digit is 4, but it's not a regular 4, is it? It's a 4 in the thousands place, so it's 4,000. Okay, but the number is not just 4,000. So who can tell me what's the next digit in our number? Alexa?
500.
500. Okay. When I put my numbers here in expanded form, if I leave blanks between them, if I leave a space, people might think that they're different numbers. But they're not really, right? It's all part of the same number. So to let people know, hey, these are all part of the same number, I put a plus sign in the middle. That way people know that this number goes with this number. Okay. Is that the end of my number, or is there still more? Oh, Kylie, I see you shaking your head. What would be next? So we have 4,000. We have 500. What's next, Kylie?
40.
40. So again, they're not separate numbers. So I'm going to put a plus sign in the middle so people know that they go back together. Put 40. Okay. Is there anything else, or am I finished with my number? Jaylene?
You're not finished with your number, so you have to put a plus sign and then put a 2.
Perfect. I'm not finished yet. I need to put a plus sign and then a 2. And since the 2 is in the ones place, it's just a regular plain 2. And this would be expanded form. Okay? Now, they also have something that they call expanded notation. Expanded notation is the exact same thing. It looks a little bit different. Kind of like how, let's say in the morning, if you comb your hair a different way or you style your hair a different way, it looks a little bit different, but is it all of a sudden brand new hair? No, it's the exact same hair you had the day before. All that's different is that you combed it a little bit differently or you styled it a little bit differently. Like if you have longer hair and you pull it back and you put it into a ponytail, and then the next day you put a ponytail again, but on the side, it's not a brand new head or a brand new hair for that day. It's just a new hairdo. My hair, I can't style my hair any differently. It just stays the one way. So expanded notation is like expanded form. It just looks a little bit different. Instead of putting 4,000, what you would do is you would put 4 times 1,000. Expanded notation shows people that there is a 4, and what place value is our 4 in? It's in the 1000s place. Just like expanded form, you don't leave the rest of the number out, you have to put it together. The part that makes people kind of confused about this one is that to show the numbers are together, they still put a plus sign, but they put this part in like a bubble. They put it inside parentheses. They're telling you that this is one digit. It's 4 times 1000, or there's a 4 in the thousands place. And then there's more. What do you think I would write to show that there's a 5 in the hundreds place? If I have to write 4 times 1000 to show there's a 4 in the thousands place, what would I write to show that there's a 5 in the hundreds place? Messiah, what would I write to show that there's a 5 in the hundreds place?
5 times 100.
5 times 100.
I know what you're in.
Okay, perfect. There's still more. How would I show people that there's a 4 in the tens place? Bella, how would I show that there's a 4 in the tens place?
4 times 10.
4 times 10. 4 times 10. And the last number, the last digit, how would I show that there's a 2 in the ones place? Alexa, how would I show that there's a 2 in the ones place?
2 times 1.
2 times 1. Oh, sorry, I forgot to put the parentheses. All right. So again, expanded form, which is our top one, and expanded notation, which is our bottom one. It's the exact same number, it just looks a little bit different. The same way that if you comb your hair different, it might look a little bit different, but it's nothing new. It's the same thing. Let's try another number here. Put my numbers back. I can build a new one. Okay, I'm going to try again another number in the thousands, and then we'll try bigger numbers, okay? Let's try to okay. Who can read that number for me? How would I say that number? Bailey, how would I say this number?
7,321.
Okay, 7,321. Let's change this. 7,321. Okay. Now I'm going to take my number, and the first thing I'm going to do is put it into expanded form. I'm going to break my number up by the place values. Who can tell me what's the first digit in that number? Or I guess not first, but what's the biggest? Place value always goes from biggest to smallest. So what's the biggest digit in that number? Bailey, what's the biggest digit in that number?
7,000.
7, and since it's in the thousands place, it's 7,000. Okay, but that's not the only digit in my number. There are more. What's the next digit in that number after 7,000? Ezekiel, what do you think it would be? After 7,000, what's the next digit?
$300.
300, awesome. 300.
And 20 and 21.
Close.
And 1.
Perfect. You can't put them together. It's got to be one at a time. Plus 20 plus 1. All right. So that would be expanded form. Now, if they want to show it to me differently, if they want to show me expanded notation, who can tell me how would I show that there's a 7 in the thousands place? What would I write here to show that there's a 7 in the thousands place. Sebastian, what do you think? What would I write to show that there's a 7 in the thousands place? Seven times 1,000. Perfect. Okay. Oh, hold on. Sorry, forgot the other parentheses. 7 times 1,000. What would I write to show that there's a 3 in the hundreds place? Nakai, what would I write to show that there's a 3 in the hundreds place?
Um, you would need to write
What would I write, Nakai, to show that there's a 3 in the hundreds place? Who can help out Nakai? What would I write to show that there's a 3 in the hundreds place? Alexa?
You can put 3 times 100.
3 times 100. 3 times 100. So it's always what digit is there times what the place value is. We put 7 times 1,000 to show that there was a 7 in the thousands place. We put 3 times 100 to show that there's a 3 in the hundreds place. Who can tell me what would come next in my expanded notation? I have 7 times 1,000, 3 times 100. What comes next for this number? Brianna, what do you think comes next?
2 times 10.
Perfect. And I like that you caught it and you fixed it. 2 times 10. All right, there's one last part to my expanded notation. What's the last part I need to add? Sebastian, what's the last part I need to add to finish off that number? Okay, Brianna. The last part I would need to add. Are you typing it in, Sebastian? Okay. Not seeing it over here. I don't know if it's just taking a long time. Who can tell me in the meantime while we're waiting for Sebastian's message to come through? What would it be to end that number? Kylie.
One.
Would it just be one by itself?
Um, one times one?
1 times 1. Perfect. Because there's a 1 in the ones place.
I get kind of confused because I've never had a number where it had one times one. It'd always be one times three or one times four or five.
Mhm.
It's my class in second grade.
So remember, for expanded notation, the first number is the digit. So the first number would be 7. That tells you there's a 7. The second number is your place value. So 1000. So you know that the 7 belongs in the 1000's place. Here, the first number is 3, and the second number is 100, because the 3 belongs in the hundreds place. We have 2 times 10, because the 2 belongs in the tens place. And the last one, we have to put 1 times 1, because the number is 1, the digit is 1, and it's in the ones place. Here. All right, you guys are good at this. I'm going to make it a little bit tougher now. Okay. A little bit tougher. What could we put? I know. Okay. Okay. Who can read that number for me? If you saw that number, how would you read it? Haley, how would I read this number?
130,102.
Okay, 430,102. Okay, 430,102. Like I said, this number is a little bit bigger. So when I make it into expanded form and expanded notation, it's going to look even longer than the other ones did. If I put this number in expanded form, what should be the first digit? What would be the first digit for this number? Jaylene, what do you think? What would be the first digit of this number?
Um, four.
Our first digit is 4. What place value is it in, Jaylene? If I go back here, what place value is the 4 in?
4,000.
Not 1,000. If I look in the thousands, there's a 0. Look where my 4 is.
400,000.
400,000. So that's what I have to write here. 400,000. If I just put 4, people are gonna think, wow, that's a very small number. But really, 400,000 is not. It's also not the only digit here. I have more numbers. So who can tell me what number comes next? I have 400,000. What's next in this number? What's the next digit? Jada, what do you think? We have 400,000. What digit do I see next to that 4? So if I use my place value chart, it can actually help me out a lot here, especially with the really big numbers. Hold on. Sorry. So we had the 4, right, Jada? Okay. So if I look next to the 4, what's that next digit? What digit is here? What number is here if I ignore everything else? I'm going to go ahead and move them real quick just to get them out of my way for now. What number is that? 3. Okay. Now, it's not a regular 3, is it, Jada? No. What place value is that 3 in? And thousands. So it's not just a regular 3. It's 3 10,000s. So when I go to write it, oops. Okay. When I go to write it, I can't just put 3. I have to put 30,000. Okay. Whenever you have expanded form or expanded notation, you never include zeros. You always skip zeros, and I'll show you why. There's a 0 here. That 0 is in the thousands place. Who can tell me, in math, whenever I add 0 to anything, what happens? If I have 5 plus 0, if I have 10 plus 0, if I have 1 million billion trillion plus 0, what happens? What does it do to my number? Messiah?
Where are the examples?
It stays the same.
It stays the same. Adding 0 to anything doesn't do anything. So when I put my numbers in expanded form or expanded notation, I always skip the zeros. You don't need them. Because if you add 0, no matter how many zeros, doesn't change anything. We skip the zeros, and we go to the next place value. Who can tell me what digit do I have here after my 0 that I skipped? Alexa?
100.
100. So I have a 1, not a regular 1, but a 1 in the... Oh, sorry. Oops. They want to write it there. We have a 1 in the hundreds place. So I'd write 100. Okay. What number would come next? So I have 400,000 plus 30,000 plus 100 plus what? What would I write next in my expanded form? Bella?
Two.
Bella, I am so proud of you. I had put that trap there to see if I could trick you, and I couldn't. After the 1, there's another 0. Like we just said, we don't put zeros. So we skip it and go to the next one. And the next one is just a 2. In the ones place, so it's not 2. It's not, sorry, it is 2. It's not 20 or 200 or 2,000 or 2 million. It's just 2. Okay. Let's try expanded notation now. My first part. What's the digit that I need? What's the actual first digit in that number? What does it start with? Violet, what's this first digit here?
$4,000.
Very close. So it's a 4. We're right about that. We have a 4. Ooh, come on. Let me just do that. There we go. So you're right. We have a 4. But look at the place value that we had. It's not a 4 in the thousands place. It's a 4 in what place value, Violet? What place value is here in our 4s?
100.
100 what?
1,000.
100,000s. So it's not in the hundreds place. It's in the 100,000s place. So it has to be 4 times 100,000. It's a very big 4. All right. What about the next number? We have a 4 in the 100,000s. What would come next? What would be the next part of my expanded notation? Alexa, what's the next part of this expanded notation?
10,000.
Okay, the 10,000s. And what number, what digit is in the 10,000s?
3.
3. So I'd have 3 times 10,000. All right. Next place value. Who can tell me? We did the 4 in the 100,000s. We did the 3 in the 10,000s. What comes next? Bella.
Is it
What do you think? So we did 3. We did 4. Then we did 3.
1?
What's the next one?
1 times 100?
A 1 times 100. Because again, I skipped the 0. So 1 times 100. Okay. What's the next one? 4 times 100,000. 3 times 10,000. 1 times 100. And what comes next? What would I add after 1 times 100? Haley?
Um, 2 times 1.
2 times 1. Perfect. Fantastic. Wonderful. Beautiful. Absolutely amazing, guys. All we have to do for expanded form and expanded notation is to break the number up using the place value. We're not changing the number. It's still exactly the same. If I put all these numbers together, if I did the addition, I'd get the exact same number I had before. Again, it's like combing your hair differently. Just because you put it in a ponytail at the back and then to the side, it doesn't mean that you have a completely different hairstyle. It doesn't mean you have a completely new head or completely new hair. It just means you combed it differently that day. So don't let the fact that sometimes they're going to show us these numbers, don't let that throw you off or scare you, because it's still the same. It's the same thing as before. All right?